and welcome to a course on exam techniques for grade 11 mathematics. Thank you for an opportunity to share knowledge on exponential rules and how they produce a solution that simplifies mathematical expressions in an exponential form. Let us see how all these come together in a typical exam session.
To simplify the expression of a fraction with numerator given by base 2 exponent the difference between x and 3 minus 3 times base 2 exponent the sum of x plus 1, and denominator given by base 2 exponent the difference between x and 2. Note that a product of powers of the same base is equal to a base raised by a sum of exponents, and then simplify the given expression, such that the numerator is given by base 2 exponent x times base 2 exponent negative 3 minus 3 times base 2 exponent x times 2, and denominator given by base 2 exponent x times base 2 exponent negative 2. Next, take out the common factor of base 2 exponent x on both the numerator and denominator. Then rewrite this fraction using the division rule of exponents so that the expression is in the order of base 2 exponent negative x times base 2 exponent x times base 2 squared times a difference of base 2 exponent negative 3 and 2 times 3. Furthermore, the expression simplifies to base 2 exponent 0 times a difference of base 2 exponent 2 minus 3 and base 2 exponents 2 plus 1 times 3. Note that base 2 exponent 0 equals 1, so that the simple equation is base 2 exponent negative 1 minus base 2 cubed times 3. To solve for x in an equation given by 2 minus 16 times x exponent negative 3 over 2 equal to 0, use the BODMAS rule, such that x exponent negative 3 over 2 equals 1 over 8. Then, write every constant in terms of its prime factors and use division rule of exponents, so that x exponent negative 3 over 2 equals 2 exponents negative 3. To eliminate the exponent of base x, raise both sides of the equation by a reciprocal of the exponent of x. That is, raise both sides by exponent negative 2 over 3, as shown in this slide. And then simplify so that x equals base 2 squared. Given the equation base 4 exponent x plus 8 equal to 9 times base 2x. To solve for x, note that base 4 exponent x equals base 2 exponent x all raised by 2. Let k equal base 2x so that the equation becomes k squared plus 8 equal to 9k. Next, standardize and then factorize the quadratic equation so that the two factors are given by k minus 8 and k minus 1. Therefore, base 2 exponent x equals base 2 exponent 3, or base 2 exponent x equals base 2 exponent 0. Since bases are the same, then x equals 3, or x equals 0. Given the equation xth root of 9 equal to 243. To solve for x, note that xth root of 9 equals base 9 exponent 1 over x. Next, rewrite all constants in terms of their prime number and then simplify so that base 3 exponent 2 over x equal base 3 exponent 5. Since bases are the same, then 2 over x equals 5. Therefore, x equals 2 over 5. To simplify a fraction given in the numerator by square root of a difference between p squared and q squared times the sum of p and q all raised by exponent 5 over 2, and denominator given by a difference between p and q all raised by exponent 1 over 2, such that p is not equal to q. First, notice that a square root of the difference between two squares is equal to this difference raised by exponent 1 over 2, so that the expression becomes, as shown on this slide, after factorizing this difference of two squares. Next, use the division rule of exponents to represent this fraction in terms of its integers. Simplify further by adding exponents of powers of the same base. So then, a simple expression is given by p plus q all raised by exponent 3. I hope you enjoyed my thoughts on exam techniques for mathematics questions on algebra. Please subscribe to our channel, like this video for more likewise, and share it with like-minded friends. See you next time!